because that is also pleasant.
Yeah. English is also very funny, eh?
Yeah.
So
especially with my Dutch accent.
We should be live now. I'm going to check on YouTube if we're actually live.
That's always good to check.
Yeah. Well, it only starts half an hour from now, so this is just half an hour to get everybody started.
But like, I don't know, you always want to make sure I've never used StreamYard before, so you always want to make sure that the connection works. And
Exactly. But we're live, and I hope the other speakers show up. I see there are some people watching already, so if you're watching, hello. Can you feel free to introduce yourself in the chat?
So out of curiosity, because Lean was also one of the organizers, I think, right?
Yes, yeah, that's correct.
Okay, interesting. So I remember a couple of years ago, I was trying to convince her to start like a PyData down south, and I think she's somehow thought, oh, PyData would be cool, but this might be easier.
Yeah. Well, we're organizing Data Science Leuven with the 6 of us.
That's a fairly big group.
Yeah. And it's precisely out of laziness. Like I don't want a lot of hassle, so it's one meeting a month. It's always the same format. It's always in the same venue. Well, now it's online, but it's always in the same venue. Hopefully also the same audience, and we have a rhythm in there, so we don't need to spend a lot of time organizing, and we can focus on the data science itself.
So do you get, because I did like your setup, like the talks are like 20 minutes, that is relatively short, but still long enough to make a point. So that's something that I did think, that's a nice touch. But do you folks have like a lot of trouble finding good speakers? Because in Amsterdam, when I was organizing meetups, that was always the hard part.
Yeah.
Getting amazing speakers to come to you, that's usually tricky. But then the thing with PyData was we also have this conference. So if you have an amazing talk, are you going to talk at the conference or are you going to talk at the meetup?
Yeah, well, PyData is famous, right? So I guess everybody wants to speak at PyData. No, I think because we're 6 organizers and everybody has their own network.
That helps. Yeah, that helps.
Yeah. I see. Wait, Amine also joined. I'm going to add him to the stream. Hey, Amine, welcome to the
guys.
stream. Hey.
Thank you. How are you guys?
I'm good. We're good. Just so you know, we're live already. We're streaming on YouTube.
Okay.
So.
Okay. So I'll try not to make shitty jokes or something like that.
Feel free. I don't care. I honestly don't care. I'm just saying that it will be on YouTube.
Okay. It will be on the internet forever, basically. Right.
What do you call a Swiss algorithm?
Oh boy.
That's what I'm talking about. I feel the punchline is gonna be good. What do you call it?
It really isn't. No, it's a neutral network.
Okay, it was good. Like the bar is set already very high.
Indeed. Vincent, your talk will be at the same level or what?
It will be a bit deeper, but there will be no learning.
Awesome.
So you guys
sorry, go ahead.
How are things going? Where are you guys based? So you, Chris, you're in Belgium, right?
Yeah, I'm in Leuven, Belgium. Yeah.
Okay, and you, Vincent?
Haarlem, which is a city next to Amsterdam in the Netherlands.
Okay, yeah, cool. How are things going there?
Oh, I mean, my house is still my house. It didn't fall apart yet, so that's, I suppose, convenient. Okay. No, it's like. I mean, this has been a rough week. Like, I was born in the US. I've got friends there. I've been seeing some stuff that I didn't want to see. Like, that stuff's like really rough. So that like, I've noticed that last week wasn't productive at all because of that. I am happy to see the Corona thing is at least probably in Belgium as well, I hope. But in Amsterdam in here, it seems to be going the right way in terms of Corona. So that's kind of nice. And that's especially nice because I'm trying to plan a wedding. Because planning a wedding during Corona is also not a great thing.
When do you plan to have your wedding?
It's the 26th of September is the formal idea, and the thing is we've had me and my soon-to-be wife have had a meeting about this yesterday. So what we're kind of looking for is like I don't want to walk around my own wedding with a conscience of, oh my God, I hope no one's going to get sick. So what we might end up doing is something with a webcam, because we're kind of like, we just want to get married. And if we can do some sort of funny YouTube thing and grandma can watch it over the webcam, I think that's going to be more fun than if my grandma has to be there in a hazmat suit, sort of fully wrapped in plastic. I mean, that also takes a bit of the magic away. Yeah.
Well, it's crazy. And you're like postponing the wedding is not an option. Like you want to get.
I mean, that's not really. I mean, the thing is, right now you can say, "Oh, I want to postpone it because then I might be able to plan it." But that's like you can play the game forever as well, right?
Exactly.
That's also the thing. So you might
especially
as well.
Especially because we never know. Like we never know what's going to happen. Like it's not guaranteed that next year. Well, I hope next year is going to be better. Everything's going to be back to normal. But it's not guaranteed, right?
Yeah, and also like, what does normal look like? Right, that might also just change, and also I get to be the Dutch stereotype. I just want to be impatient. I just want to get married. So there's also some nationalism there, I guess. I don't know, but no, like, well, I think one thing that is also kind of nice is. I mean, like one thing that we've been thinking of, and if some of my friends are watching this, it's gonna suck because the surprise will be gone. But I don't know how Belgian weddings are, but in Dutch weddings at least, like it's the hooray ceremony moment, and everyone just goes for coffee and cake. It's like the Dutch thing. Like there's always a coffee and a cake sort of during the reception. I don't know if that's the same in Belgium.
Not always, no, but I see what you mean. Yeah.
So what we want to do is like everyone who's tuning in from home, we're going to send everyone a cake. That's kind of the idea. So like, and the thing is, like, you can still have a wedding that's a memory to everyone. Like that's more the thing we're trying to accomplish. The only thing that's tricky now is we have to figure out what's the cool memory going to be, so to say. That's the main thing that's tricky.
Yeah, exciting times to have a wedding, I must say. You could also see this as an opportunity to like, hey, I'm only going to invite like the 50 people I actually care about, and not like the 20 aunts and uncles and nieces and nephews that I have. Like,
how big is your family? 20?
Yeah. Well, I should be careful here because I had my wedding already, and some people might be insulted here. But no, I mean, in a wedding, you always have people that you kind of have to invite, but don't want to invite.
Sure.
Well, so there's so I mean, every family I'm sure has that, but the main thing here is, I think if you want to keep like a good 2 meters distance, a lot of venues you can only have 20 people there. Well, like if you're normally in the bar and it's kind of crowded, I mean, you need like 5 times the space all of a sudden. So many wedding venues cannot even handle, I think, 30 people. If you really want to be strict there with the 2 meters, right? Which, I mean, I have a grandmother, and I'd like to be a little bit careful with my grandmother. But then, that's not going to happen.
Yeah, no. But that's the difficult thing with the corona, right? You have the official rules, but I don't know anybody who like follows them to the exact rule. Like a lot of people I know are super careful with corona, and they try to follow the idea of the rules, but the exact rules that's at least here in Belgium, it's so complex that
it depends on where you are, I'm sure.
In France it's the case as well. Well, starting from like last week, terraces has started to reopen. Like some bars, at least in the outdoors, have started to reopen and stuff like that. So people are starting going out more and more. People are having picnics in parks, and maybe they're not necessarily respecting the 2 meter distance per se. So you can already see that people are slipping back slowly to the old life, which it's hard to completely blame them because I imagine it was rough. But I do think there will be. Hey, hello, hey Sam.
Hi guys.
Just so you know, you're live on YouTube, but keep on eating. That's fine.
Just know that it's live, and the way that you chew will be judged.
Yeah. No, I think of the 4 of us, I have the best corona here, so I'll take that.
I basically my first appointment, the first person I think I saw. The first other person I saw after the confinement was my hair guy. It was really the first person. Like I had a beard, really like it was pretty cool. Like I had a beard like this, and I had the hair and everything. So no, really, I think I still have some pictures. I will not post them here for sure. Maybe someday.
Oh man, that's like, but still, I'm not gonna say it's better than what we did, but like, at some point, my hair was like I really get like a mathematics professor haircut at some point as well. Like basically what you're describing, like the oomph, that thing. So my girlfriend said, Vincent, I won't stand for this. So she went onto YouTube for like a tutorial.
Oh man.
So my haircut for the last month essentially was like this bit all super short and here just as normal. And the main reason was, as she was cutting, at some point she saw what I looked like, and with that old haircut, she couldn't look at me with a straight face without laughing out loud. So she wasn't able to cut me anymore, because every time she was going to cut one hair, she just laugh out loud. So yesterday I actually went to the barber again.
I didn't take the risk at all. Really. Like I preferred. Yeah. Otherwise I would have been confined maybe for a month more. The time that my hair grows back or something like that.
Yeah.
If I cut it myself.
But just to check, I mean, you're because you live in Belgium as well, right? Or Leuven?
No,
or...
I live in France. Paris.
Ah, okay.
Yeah, we took the opportunity. Well, I say we, but it's actually Lynn who organized most of this. We took the opportunity to find some international speakers. Now that we always do it physically here in Leuven, so our speakers are from around here. But now we actually get to invite someone from. I thought from Berlin, but yeah,
sorry,
almost, and then some from Paris, and like this is a nice international meetup today.
Yeah, so one thing, I mean, I'm in developer advocacy, I suppose, nowadays. So for me, it was kind of easy to just tell the meetups, hey, I'm available. In the last month, I've spoken at like PyData India, which usually you have to be on an airplane for, but like within a week, hey, I'm speaking at India, like. In terms of if you're a meetup, you want to get international speakers, you can get really good speakers now.
Mm-hmm. No, indeed, and it's easier. Well, the stupid thing is that it's always been possible, right? You've always been able to do, but nobody did it. It's the same with video conferencing with clients, at least for us. Like, yeah, no, I'll go there physically. We have to see each other face to face. Then it's not possible anymore for 3 months, and then you realize, well, you know what? You can just do this in a conf call just as well, right?
Exactly.
Yeah.
I mean, I will say, at least for the meetups that I tend to, I do miss meetups, like the whole networking thing part of it. I really do miss that. And also, like, when you walk around a meetup, you'll have like 20 groups of people talking randomly, and usually there's always like one person that I meet who I would not have met otherwise, and that's always kind of cool. Like some student who has like a really cool thesis, or like someone with a hobby project. I mean, that sort of thing, I suppose, a little bit less natural this way.
Yeah, indeed. It is. That is the case. I am quickly going to console my son because he's very sad that he sees me, but he can't be with me. So I'm going to quickly mute myself, and then I'll be back in 5 minutes.
Sure thing. But I mean, just because where in France you live?
In Paris.
Oh, okay, the big city, Paris.
The big city. It's going okay. The weather. Well, we had some pretty great weather when the bars were closed. But once they opened, the weather became shitty again.
Yeah, the rain, right?
Exactly. The rain came back and everything. But aside from that, it's going okay. And how are things in Haarlem? Are things opening up? I don't actually know what's going on
I think it's
right now.
I think it's pretty much the same across Europe, to be honest. Because my colleagues in Berlin, I've seen photos where they're outside eating and someone else is cooking for them, which hasn't happened for 3 months, right? No, like one thing I can imagine that's different is like Paris, as like the few times that I visited. I mean, Paris is stacked on top of each other. It's a lot of people live there, not a whole lot of space and stuff. So it's pretty dense. And that is a risk, right? I mean, if a lot of people living together,
definitely a big risk.
Yeah.
Well, that's why I think. Well, the Paris had obviously the most cases, and it's still so. Basically, the rest of the country. Aside from Paris and maybe like some other region, the rest of the country is opening up more and more.
Okay, so Paris is still kind of
exactly. Normally, like in the rest of the country, the bars and the restaurants are actually fully open. Obviously, by respecting, there's a lot of new procedures to respect,
with rules,
but they're open with the rules. In Paris, only the outdoor spaces are open for now.
And that's a similar thing here.
And the situation will be reevaluated. Like sometime during the end of June, things seem to be going. The numbers look okay, but again, you never know. Like especially you it's hard. The measurement problem in the COVID
Yes,
crisis
no,
is
it's
quite a
there.
hard problem.
Yeah, no, it's definitely there. And also the thing is, like, you've been inside for so long, so everyone wants to have a party at their friend's house, right? I mean, that's also not helping, obviously.
Exactly. It's hard. Like, do you guys think there will be some long-lasting behavioral effect after this? Like, people will be, in general, more careful. Like, they will be respecting the social distancing measure even after the crisis is long over.
So I think this is going to be sounding quite cruel, but I can imagine at least it's a lot easier to be super aware of this if, like, you know someone who got very ill, right?
Course,
Like, and you know, a lot of people got very ill, so it'd be really weird if it had no effect whatsoever. And at least in the Netherlands, one of the things that you do kind of hear is that, you know, hygiene in meat factories, that is being reviewed now just in case. Right. So in that sense, I do think this has been a nice little warning signal that, hey, governments have to organize better around this theme. In some sense, you could argue we might have gone lucky. I mean, imagine that the whole lockdown started 2 weeks later. I mean, that.
Yeah, of course.
So
you do think it's gonna basically, even long after the crisis is over, there will be some long-lasting cultural changes or behavioral changes or even organizational changes?
I mean, you'd be a weird government if you didn't learn from this, right?
For sure.
Like,
For sure.
I
But
mean,
the thing is that the crises happen all the time, and a lot of government, they don't necessarily learn from it, right? Like, it's
true. But I mean, well, one thing I suppose, I mean, you always have the person from the left and the person from the right, and because the person from the left doesn't want to listen to the person from the right, but I will, like, it'd be weird if people didn't look at COVID and sort of go, "Hey, that's a common enemy," right? Like,
yeah, for sure.
Like, no one's gonna be pro-COVID.
Yeah. Fortunately, it's the case. But yeah, I see. Okay.
But what the real effect is going to be, we're just going to have to see. I do think, I think a lot of travel is going to be different, though. Like, I don't like right now that this could have been a conference call, and I mean, conferences are still going to be out there. But are you going to really fly to, like, a different country just to have a meeting? Like, are we really going to do that again? I mean, that's feeling.
I think this working from home policies, I think a lot of companies, because they were in some sense pushed into implementing work from home policies, and for a lot of them, it worked very well. I would argue maybe for most of them, it works pretty okay. So maybe it will be a long-lasting effect. Basically, all of them will start being more open to remote working.
Because out of curiosity, both Chris and yourself, before Corona, were you already working from home or remotely, or were you still going to the office every day?
I went to the office most of the days, or at least I went to clients most of the days. I think maybe 1 day out of 5 max I work from home. No, not even that. But my office is within cycling distance of my home, because so then I'd rather be at the office than at home, actually.
Same here. I would say 1 day, like it's pretty recent. 1 day a week or something like that. So it wasn't something that I've done regularly. So I definitely needed to adapt to the change.
Because one thing I have noticed, so the role that I have is fully remote. So before Corona hit, I was already kind of going to this remote thing and trying to figure that stuff out. And I ended up actually renting an office for like 1-2 days a week. And for the main reason that, but one thing I thought was really cool about it is the office had, like, it's not allowed to be super expensive, and the people who work there just need to be awesome. Like,
yes, exactly.
It's really rare that you can pick your colleagues, and that was something that's actually kind of interesting, because usually you can have an amazing job and bad colleagues, right? But now I can say, no, the office I go to, there just have to be extremely fun and interesting people there.
I agree.
And it's really rare that you can pick an office that way.
For sure. I think, I think if I, for instance, if even after this I continue working from home and everything's okay, I'll probably like go to a co-working space or something like that. I do think it's like just having people around is actually quite important. I think
And you have to get out of the house. Like, that's also
yeah,
a thing.
for
You have
sure.
to get out. You have to get out of the house.
For sure. Otherwise, I'm preparing my breakfast while I'm in my first meeting of the day or something like that. Then you don't know when your day ends.
I mean, the first week of Corona, everyone was sort of making a joke like, I'm wearing pajamas in this meeting. Like,
Exactly. I
but
don't think it was a joke. I think it was.
no, okay. So I also think it's pretty factual, but I mean, but that's fun for 1 week. But after a week, you gotta adapt. Like, you gotta do
For
something.
sure.
Yeah.
For sure.
But yeah. What's the main thing that you miss from Corona, like from a tech perspective, right? Because online meetup, this is pretty cool, right? We can all sort of join in.
Yeah.
But I have noticed that, you know, it's nice to be able to just hang out with your peers and whiteboard or something.
Yeah.
That is hard to still do digitally.
We did talk about it like with some colleagues recently about the whiteboarding, like, and we started seeing if there is some good like virtual whiteboarding solutions, like, I don't know, getting some tablet or getting like like a pen or something.
I have a recommendation if you're interested.
Okay, what are you using actually? I am interested.
So I'm a bit of a nerd when it comes to this. So I used to have an iPad Pro. Oh, look, it's Mini Chris. So if you're on the bus, I can highly recommend this one. This is an e-ink.
Yeah.
So if you want to eat, you might want to read some data science articles as well. So this is basically what's especially cool is the pen you get for this thing is the same pen you use for the other thing. So you can just draw on this one and that one. But this great for PDFs, and you can make notes, and it's black and white, and you can just sync with the laptop. So that stuff's great.
Okay, that's pretty cool.
But part of my work is, can I share my screen actually?
Yeah, you can. Actually, that's one of the things we should test before the meeting starts.
Okay, so we're testing it now then.
Yeah, go for it. Go for it.
Chrome has lost permission to capture your screen. Follow these steps. Okay.
Yeah, you need to go to your settings and then say allow. And then if you have a MacBook, it says like, hey, I need to reboot. But you don't have to reboot.
Okay, good.
In the meantime, you might see a little baby here in the screen, but because she was a bit crying all the time. Yeah, I'm a terrible host. That's why.
Don't worry about it.
I mean, you got to take care of the little people too.
That takes most.
There is no age limit to start data science. So
she'll have a bright future ahead of her.
I'm sure she will.
Hey Vincent, is the sharing of your screen working? Yeah.
I
have to add it to the screen. Here it goes.
Oh,
okay, good.
Perfect.
So here's the thing. If you have a Mac, there's this app called ScreenBrush, and and this is a Wacom tablet. It's the cheapest one you can get that has the screen. I think it's like 300 euros or something like that.
Okay, got it.
The cool thing is there's this USB 3 cable in here, and I can fold in these. I can fold it in. So essentially, this is also a screen that you can bring with you, like in your backpack. And
that's pretty cool.
That is a feature that's actually nice, because it also means that you can carry this with your laptop, and you always have a second screen with you. Now, but the cool thing is, if you combine that with an app called ScreenBrush, then I can sort of, let's use the color white, because that is something that you're probably going to see a bit nicer. But then I can draw these sorts of stick figures during the meeting.
Okay. That's pretty cool, man.
So this is pretty cool, but you also have apps, like if your colleague also has one of these, I think there's also some web apps like Whiteboard with a Y, and then you can have like one guy share that on Zoom, and two people can share it, like draw at the same time.
Okay,
it's not the same thing as actually whiteboarding, because usually if you're whiteboarding, one person's allowed to draw and you pass the marker around. But it's close, and that's the cool thing.
Yeah, that is pretty cool.
I would say this is one of the things I miss the most. There's really like the whiteboarding sessions, and also just the impromptu. I would say also the impromptu discussions, and like on the coffee machine, and you start just talking or brainstorming about something in a very informal manner. Hello.
Yeah. Hey guys, just a sec. Can you, Vincent? Can you go off sharing the screen so I can test whether mine works?
That's probably a good idea. I'll stop.
Just to check. Can you see mine now?
Oh, recursion.
Wait, let me show you. Can you see it?
Mm-hmm.
Yes.
Okay, thank you. Let me go out, stop sharing, and it's back to you, Vincent.
Yeah, maybe I will try sharing mine as well. That way, that way everybody. Okay, so you're gonna see some recursive stuff as well. Okay.
Yep, recursion.
You see right? Boom. Looks. You can see my slides, right?
Uh-huh.
Perfect. Okay. Nice. Everything's working. Okay, I think people are completely getting used to virtual stuff, so no technical problems anymore.
Everything just works and the world is perfect. Rainbows, green fields.
You're on mute, Chris.
Oh.
Yeah, sorry. Now we have StreamYard and that works. But I used to try to do this with an application called OBS or something. Oh man, it was super complex. But this one is quite easy actually, so it's all good.
So
okay.
I think
I didn't know this app.
A colleague of mine uses OBS, and I think the impression I have of it, at least, it's a little bit less beginner friendly, but you can do so much more with it. It's one of those apps where you can really sink your teeth into. But if you just want to run something online, then I can imagine it's probably too complex for what you need.
Yeah, for sure. For sure. So yeah, impromptu discussions. This is something I miss. What do you miss? What do you miss the most?
Well, so meeting, I'm going to say that this is going to sound slightly disrespectful, but I like to meet weirdos, and I think if you go to like a program meetup, you meet like fun weirdos. That's the thing, kind of. Everyone has their own little hobby project, and then you meet this guy who's like super excited about JSON parsing, and you kind of go, "Why is that so exciting?" But then
he'll probably convince you. You'll probably become a JSON parsing enthusiast by the end of the discussion or something.
Yeah, no, the guy actually had a couple of really cool points. I remember this one time we had someone over at the PyData, and he was like really bitter that pandas didn't want to accept his PR. But then he figured, okay, instead of that, I'll just talk about it. I mean, that sort of stuff is fun. Like, people always have fun side projects, and especially if you go to the I no longer help organize it, but especially the PyData Amsterdam conference, we like to think that we kind of pride ourselves that we also invite the people who didn't do anything meaningful, but it's really fun what they've accomplished. So we had a guy who downloaded all metal lyrics, like all the metal bands he could find, basically to research what is the least metal word out there.
Okay, and like, is it online, or can you say what is the least metal word? Can you share with us this?
Yeah. So you can watch the talk. I think the talk is quite fun. But the least metal word is cooperation. and I'm going to quote him. So I think Ian said something in the lines of the fact that cooperation is the least metal word is not itself super surprising. But the fact that the word is even in a lyric in the first place, that is surprising. But I mean, that's the stuff that I kind of like. It doesn't have to be useful. You just do it for the fun of it. And a computer is kind of like an extension of your mind. You can sort of do things that were like super impossible 10 years ago, but are super easy to do nowadays. Just for loop it and you're done. That inspirational aspect of it. That's something that is slightly hard to do online, I think.
Yeah, I understand. But for sure.
Yeah, one thing I miss is in the Data Science Leuven, so the physical meetings or meetups, like we do the meetup in the auditorium here in Leuven, but then after the meetups we go for beers, and there's a bar right next to the auditorium. It's actually part of it. The auditorium is in the bar, basically. Well, it's part of the venue.
Oh,
and
you
it's
Belgians!
Really nice to just you have your session in the auditorium.
Yeah,
I know we're alcoholics, I guess, but you also have a soda at the bar, right? So it doesn't have to be alcohol.
Oh, sure, no.
You just walk like 50 meters to the bar. It's super nice.
Like the Belgian bars are in fact quite amazing in general. I think it's different than Dutch bars, but it's also nice that there's this informal aspect to it.
Yeah. All right. I'm going to try to get started, but I literally have a crying baby with me. My wife should pick her up any moment now, but she's dealing with the other baby. So it's a bit hectic today here in our place. But anyway, Luckily, I'm only the host, so I don't have to do a lot of talking. I'll let you do the talking, most of the talking. And actually, Vincent, like you talked for half an hour already. Like the half an hour of waiting, like it flew by. Like...
I can talk for 6 hours if you want. I mean, that's fine.
All right, but so well for everybody watching, welcome to the 28th, if I'm not mistaken, 28th Data Science Leuven meetup. I'll share my screen this time. Because I prepared some slides to welcome everybody. Yeah, we also see some inception there. Boom. Oh, sorry. Present. There we go. Yeah. So the 28th meetup, the talk starts right about now. Let me introduce the speakers who you've seen so far. So the one you've heard talking most was Vincent. Vincent Warmerdam, I hope I pronounced it correctly, from RASA Berlin. But he's actually based, I learned today, he's based in close to Amsterdam. And he will talk about why transformers grab their attention. So let's see what that's all about. Next up is Mohamed-Amine Benhalloum. I hope I pronounced that correctly as well.
It's perfect, yeah.
Thank you. From Criteo. So he's based in France, and he will be Paris, and he'll be talking about the scalable representation learning and retrieval for personalized advertising. So that's a mouthful. I'm looking forward to that talk. And then last but not least, we also found someone from Belgium to talk. So Sam Vandormael from Altares, and he will be talking about RPA and compliance. That's it actually for me. I hope you enjoy the talks. And with that, I'll give the word to Vincent, who can start his talk.
Sure thing. I'm just going to set a timer so I don't talk for too long.
Yeah.
And which I think is a good thing. And I'm going to click the share screen button as well.
Awesome.
And,
Here it comes. Yeah, you're live. Yeah.
People can see the screen and they can see this little doodle. Yeah, I can see this works. All right, perfect. So hi, everyone. My name is Vincent, and I work at RASA. And my job essentially is I'm a research advocate. So I sit between the developer advocates and the research team. And part of my job is to make sure that whatever complex algorithms that we come up with, that I make sure that they are well understood by our community of people who like to make chatbots. So what I would like to do today is explain how transformers work and why they work quite well for the problem that we have. Because this is the problem that we have. When you're building a digital assistant, you're going to have a conversation. And it's really hard to predict how the conversation is going to go. So you might say hello. And then you might say something like, I'd like to have a pizza. And then you might have a chatbot that says, okay, what kind of pizza would you like? And then this is the flow of the conversation, which is then interrupted by this human saying, oh, by the way, are you a human? And then it would be nice if our digital assistant was able to say, no, I'm actually a chatbot, but what kind of pizza would you like nonetheless? We'd like to have a digital assistant that's a little bit more than just action response and a little bit more what context of the conversation are we in and what's the best action that we're going to do. And that's actually kind of a tricky problem because if you think about all the stuff that you can detect in this conversation, you've got these entities that you want to detect because a user might have the intent of buying something, but you don't know what yet. So you have to detect that it's a pizza that the person would like to buy. And there's intents, like at the moment the user is saying something, that user has a certain intent and you would like to detect that. But those two things you can detect, but you also want to detect what the next best action is given the sequence of intents and entities that you've detected. And that's actually kind of tricky for exactly the reason that I've just told you about. A conversation can get interrupted. It can be in a flow, but it can be interrupted at every single turn. So you want to have a system that's robust against that. So I hope it's clear that this definitely goes a bit beyond how people use scikit-learn, because in scikit-learn, X goes in and some prediction goes out. And what we're interested in here is, hey, there's a conversation happening, and I would really like to detect these intents, these entities, and these actions as they happen in real time, based on the entire sequence of dialogue I've seen so far. So it turns out that there's this really cool new technique. It's called transformers. And then it's my job to kind of explain how they work. And they can get quite complex. So what I'm going to do is I'm just going to give you an analogy first. And we're going to start from there. So what you see now is kind of like a time series, right? And what you see is that we're trying to figure out how we might be able to make this time series better. And what we could do is we can sort of make a bit of a smoothing appear here, right? So we can say, hey, there's a little bit of noise in this time series, but maybe we can take the original time series and transform it such that we get a new time series out that's better for what we're interested in by smoothing this. And there's multiple ways of smoothing, and you see two examples over here. One way of smoothing is by saying, hey, we're going to have our attention, like the way that we're going to smooth is going to have a bigger sigma. So we're going to average like a little bit more broadly, whereas the second drawing that you see here is being quite specific. And if you're doing a time series task, I think I can argue that the red line that I end up with might have more context, might be more useful than the original data points that I start with. So there's this filtering step that's happening here. For time series, I can argue this is useful. Now, what a transformer tries to do is exactly the same thing, but for text, typically. It doesn't have to be text, but that's the idea. So how does that work? Well, let's first zoom in on what's happening here. Because what we're saying here is, as far as a data point xi is concerned, that's the data point, I guess, this dot over here. But as far as this dot is concerned, this red line over here, like this curve, so to say, we're basically saying, well, that point is going to get reweighed using these weights. That's the smoothing effect that we're gonna have. And the hope is that if we do that the right way, that we get a new red line that we see on top that is going to be more contextual. That's going to have a little bit more context. So let's apply this on text now. What you see in front of you now are two different sentences. You have bank of the river and you have money on the bank. And I hope that you would agree that the embedding that I have over here, right? So the vector that belongs to this token bank, it would be nice if we can give it some context such that the vector here is different than the vector there. Because given the context of this entire sentence, my belief of what this vector should represent might be able to update. However, I hope that you would agree that we cannot really apply the smoothing in the same way as we did before. Because proximity, in this case, I don't think that that's going to be a very valid reweighing scheme. Two words can be close to each other in a sentence, but still have very little to do with each other. So we're going to do a reweighing scheme, but we're going to do it in a way that we're not going to reweigh based on distance. We're going to reweigh based on word meaning. That's the gist of what we're trying to do. And one way of getting there, and it's a relatively simple operation, but one way at least of getting there is to say, you know what? If in this sentence over here, I want to add context to word vector 1, if I want to know how similar word vector 1 is to, let's say, word vector 2, a way to measure that is to say, you know what? Let's just do the dot product between the two. And if I do that for vector 1 and vector 2, as well as for vector 1 and vector 3, odds are that you're going to get this effect where bank and river, the word bank of the river, that's been used before. So then by doing this dot product, you might get this thing that says, ah, yeah, this is a good relationship and that has a high relationship, and a similar thing over here. And again, this is a way to quantify our reweighing scheme. And I hope that you might agree that if you multiply the word vector for bank with the word vector of river, that you're going to get a different context than if you were to do the same thing with the word vector for money and the word vector for bank. And that's kind of what we're interested in, because bank of the river is a different context for bank than money on the bank. So there's something there that we like. And we can do this with pre-trained word embeddings as well. So that's also kind of nice. We don't have to do any training to do this operation. One thing we might want to do, though, is we might want to normalize this. So we want to have reweighing schemes, so that's a probability distribution. So it would be nice if all of this were to sum up to 1, right? So that's an operation we would like to still do. That's a step we would like to do still. But what we then have is we have weights. Pardon. So we have these weights. over here. So we know the weighing factor for the first vector, for the second vector, for the third one, for the fourth one. That's what we get out of this scheme. And that means that I now have this very fancy operation that allows me to say, I start with these word embeddings. And if I want to have a more contextualized representation of this one embedding over here, then this is the way that I'm going to calculate it. I'm first going to do all of these cross products. Oops. I'm first going to do all of these cross products that you see over here. That's going to give me these weights. And these weights I can use to reweigh the original vectors over here. And I can repeat that for every single vector. That's a bit elaborate drawing, but this is the basic idea. And I hope that you kind of see the analogy with this again. If I look at a token that I have at some point in time, then if this were a time series, then I might say, okay, this is the way that we're going to do this reweighing. And by reweighing all the gray points that way, we have a better, smoother line over here. And instead of doing it with proximity, what I'm doing here is I'm doing it with the meaning of the word via the word embedding. That's the idea, at least. I believe I drew that here in the next slide. Yeah, so we have a reweighing scheme based on time distance, and we have another reweighing scheme based on embedding similarity. And what's kind of nice about this, if we think about what you can do with this, right? We have an operation of sorts. We have word embeddings going in, and we have word embeddings going out. So that means that I can take these operations and sort of try to get them into like a layer, the neural network layer of sorts. So let's call that the self-attention block. And we have word embeddings going in on one side and contextualized word embeddings going out the other. And I could put all of those word embeddings into a matrix. And if I were to repeat the steps that I've just done more formally in terms of layers, then you can say, hey, you do one matrix multiplication, then you normalize. And what comes out after the normalization, that's another matrix multiplication. But this is another way of declaring what I've just done. It's just a little bit more in a linear block format, so to say. But I hope that if you look at this, this can be a Keras layer, right? This is something that you can click together in a neural network. And what's interesting about this particular neural block is that the order doesn't matter. If I were to change the first token with the fifth one, I mean, yeah, the word embeddings order at the end also are different, but the way that I'm recalculating the context is the same. And this is also task independent. Like, I'm not updating any trainable weights inside of here. I'm just taking my word embeddings on the left and different word embeddings come out on the right. Because the approach here is that we're using something of a self-attention mechanism. Now, what I'm going to do is I'm going to take that very idea and I'm just going to draw that out. I'm going to put some linear layers here. That's sort of the idea. So I have a linear layer over here, another linear layer over here, another one over here. And I'm going to have trainable weights this way that I'm going to be able to pass around. But the only thing I'm doing is I'm just adding some extra dense layers in this drawing. That's the idea. And I can give this a name, but it's the exact same idea. I just have some extra linear layers in this scheme over here. And the benefit of this, I can still totally draw like a box around it and call that like a linear layer block, so to say. But the nice thing about this is that I now have weights that I can actually train for. So that means that if I have some sort of a classification task over here, I have this self-attention mechanism, but I also have weights that are able to train towards a specific task. And what I can even do is I can say, well, you know what, let's not just have one layer here. Let's put a couple of the layers here. Right? We can totally do that. And then we can have a couple of these matrix multiplications happen in parallel as well. And that it would look like this. And it's a little bit more complex, but the only thing that's really happening is the same drawing as before, but in parallel. And what I've drawn here Well, if we take our first attention block and we put our new drawing in, I'm going over the steps relatively quickly, but I do hope that you recognize that, yeah, it's still more or less similar to what we're doing here. It's just with word embeddings. And if you were to get the paper next to it, what I've just explained, some of you might have seen the attention is all you need paper, but in essence, what I've just explained is this part from the paper. If you take a look at the attention is all you need, the main component inside of that layer is this one multi-head attention block. And that block is exactly what I've just explained. And then I would also argue that the main thing in this entire transformer that is doing most of the work is this attention mechanism. Because the rest is really just adding a constant, doing normalization and a feed forward layer. The main component of what is happening here inside of this transformer is that multi-head attention that I've just shown you. And the idea mainly is we're able to say the word that we're currently evaluating, the context from that word is a combination of all the words that I see in the current sentence. And it's a fairly elegant way of thinking about how to handle context as you're seeing multiple things over time. So again, I've gone over the last bit relatively quickly due to the interest of time, but I hope that we at least feel this intuition of, hey, yeah, we can do something like this, but the main thing that is now different is we're using text instead of time, and that means that we can do this cross product between word embeddings. And that's nice because we can get a similarity measure out of that. So how do we use this at RASA? Well, we have a couple of open source tools and a couple of algorithms. So one algorithm that we have is an algorithm called diet. And in essence, what it does, it is able to take text, like a single utterance, so to say. And it's like, let's say, this bit of text over here. And what diet is able to do is just apply a transformer to take the word embeddings of every single token here to find both this entity as well as this intent. We call that architecture diet. Here's the diagram. It's relatively complex, but this is a neural network that we've designed that is able to use, I would argue, mainly this transformer layer over here. But the interesting thing about this transformer is that it also goes a bit beyond. We don't just use it on text, we also use it on non-text. And in the last 5 minutes that I've got, looking at my clock, what I just briefly want to do is show you how we deal with that problem of dialogue interruptions, because we use a transformer for that mainly. So let's say that I have a sentence that says, I'd like a pizza. And at some point in time, this is the dialogue that's coming in. And at that point in time, for that one utterance, you can imagine that I have an intent classifier. I might know what the intent is for that utterance. And you might also be able to imagine that I have an entity available. Like the user wants to order something. What do we want to order? Well, a pizza. We have a different model that gives us that. And it might be the case that I also know some other things at this point in time. It might be the case that I know your address. There's some other long-term information I know about the user who's currently talking. And let's also say that I know the previous action. That's to say the previous action that this digital assistant made. Then that means that at some point in time, I have these features available to me. And what I would like to have is some sort of a model that is able to take those features and turn it into an action. But the thing is that I don't just have those features at one point in time. I have them for a lot of time steps because I have a dialogue. If a user takes one action, then I have one more feature that I can add here. And what we do at RASA, we have a model here, but the main thing in the model that we put there is a transformer. That's the main item that we put in there. And ever since we've done that, we've noticed that we're able to handle different types of conversations. And in the interest of time, I'm just going to skip the details of the model. I'm just going to give you a demonstration of what the transformer is able to do for us. So I'm just going to skip these. What you're looking at now is a configuration file inside of RASA, and we call this a story. The idea is that you can define an intent, and then you can also define an action that the chatbot should make. In this particular case, I've got a chatbot where you're able to say hello, and then the chatbot is supposed to say hello back. I can then tell the chatbot to start counting, and the chatbot will then just perform a countdown. And we have these different actions that it will follow. So it's going to start at 10, then at 9, then at 8, then at 7. But what I am able to do as a user is I am able to interrupt the bot at any point in time to ask it whether or not it's a human. The bot is then supposed to say, yes, I'm a bot, and immediately afterwards continue with the countdown. That's the idea. We'd like the chatbot to be able to generalize over that. The only thing is I don't have a full training set where after every single count moment, I interrupt the chatbot. It has to learn this on its own. So what you're able to do inside of RASA is just do an experiment with that. We have a configuration file. And what you see here is a demonstration of a conversation if we have a transformer that's only looking back for one time step. And if we're looking back for one time step, we can say, hey, chatbot, please start counting. And I can say, OK, but it's not really capturing it appropriately. If I give it a transformer over here that's able to look a little bit further back, then we see that it's doing a whole lot better. It starts at 10, 9, 8, 7. I ask it if it's a chatbot. It says no, then starts counting at 6 again. But if I were to ask again if it's a bot after time step 5, I get confused. And the reason is because in this data set, we never ask, are you a chatbot after time step 5? That's not in the training data. But the moment that we say, oh, could you maybe have a history of 10? Then it is able to fully capture this. And the interesting thing with a transformer here, if you just think about how the transformer starts learning, if you haven't given a transformer any data yet, the context of where it's going to look is not just its neighbor. A transformer, without seeing any data, will think that the far history is just as valid as the close-by history, ignoring some details. But if you were to think about a recurrent neural network, it will start listening to its neighbor unless it's seen a whole lot of data suggesting that it should look further. And that's an interesting thing. And we like to think that that's maybe the reason why transformers work quite well in some of these natural language programs. But the main thing that I found interesting is that even if you don't have word embeddings per se, because we don't have word embeddings when we have these action spaces, even then it seems to work really, really well. That's the main thing I just wanted to share, to be honest, also in the interest of time. If you're interested in more of these things, though, do know that I have this YouTube channel called The Algorithm Whiteboard, where I take a little bit more time to go into these algorithms in depth. So if you're interested in these transformers, definitely go there. And it's part of my job, so you can also request content from me. If there's anything that I've maybe skipped in the natural language processing realm, but you think, hey, that'd be interesting to know more about, hit me up on Twitter or on LinkedIn, and I'll gladly make some more of this content. Also, a small pitch. We have a free conference next week. So if you're interested in these digital assistants, definitely check us out. We have some great speakers. Some of the folks from Spacey also going to show up. So if you're interested in learning more about that, you can definitely join this free conference. It's also online. And then I think we have like a couple of minutes for questions now, right? If I'm not mistaken, Chris?
Yeah, that's correct. That's correct.
Okay.
Well, thanks for the presentation, Vincent. I posted a question on the chat channel of YouTube. So if you have a question, if somebody has a question, feel free to post it in the chat box. Vincent, for you, it usually takes a while before questions appear, but I already see one.
Yeah, from Sophie.
From you know her probably. Yeah, I don't know if you can. I'll read it out loud for people who don't see it. But she says there can be different kind of
Okay.
Hey guys, sorry, I got lost myself actually. My internet disconnected.
That was you, right? Okay. I thought it was. So I just went on YouTube and I saw myself like alt tabbing. So I was wondering if it was me.
Yeah, no, sorry, it was my internet. But I'll ask the question
Sophie had a good
again.
question, so let's pick that one up.
Yeah, so I'll read it again and then you can go. So she says there can be different kinds of interruptions in the chat flow, like asking, "Are you human?" is obviously unrelated to the rest of the conversation. But what if the user suddenly says, "Oh no, wait, I want to order fries"? How does the bot know not to come back to the pizza question after dealing with the question for fries?
Good question. So one thing in particular, so we do care about the "Are you a human?" question in general. It's something I just want to point out. One of the things we wouldn't want our chatbots to do is pretend that they are a human being. So I do definitely agree, like, "Are you a human?" is obviously unrelated. That said, it is one we would like to get right. There's ethical concerns that we as a company also have with our technology stack. So I will defend you have to be able to catch that at the very least. The idea that there might also be some other interruptions is certainly valid. What you can do inside of RASA is you can give the chatbot examples of how the dialogue flow should occur. So one way of guarding yourself against this is to say, okay, maybe the user wants to go like a step back into the funnel. So one way to guard yourself against that is to just have a couple of stories that resemble that quite well. This is also something that you can learn from the data from just users that are interacting. So as long as there's an example of it recovering, then that's the pattern that the chatbot will learn. And the transformer helps out a lot there. That's the short answer for that. And there's other people asking for a joke, I suppose. But let's see if people have like machine learning related questions, because I have one good Swiss joke to conclude this with, I suppose. But,
I heard it already. It's amazing.
No, I got a second one.
It's even better than the first one. Okay.
Always have two jokes about Switzerland.
All right. Sophie, was that clear to you? And if so, does anybody else have a question for Vincent? If not, I'll probably have a question or two. Waiting until some other people have responded, Vincent. So I'm not super well versed in what you just explained, but I wonder the kind of learning that you applied here is for you specifically apply it to chatbots, because I guess that's probably what RASA does. But
yes, you'd be correct to assume that. Yes, yeah. It's the main thing we do.
But do you see in NLP? Do you also see other areas where you can apply this? That is, because in chatbots you have this interaction flow, right? You post a message, you get a response back. Would you also be able to use this on large bodies of text, do you think?
Yeah, so someone I know from PyData Amsterdam had a really cool use case. So what you can imagine that these transformers are really good at as well is if you have like a super long one, right? Like one that could fit a document, you might be able to get some subtlety out of this as well. So I think the use case here was people were parsing like financial reports from companies. And if a company were to say, we have some exciting challenges, then the sentiment should be negative, right? But word embeddings alone will not be enough to detect that. It's the combination of those tokens that might give context to each other that are able to sort of come together with a representation that suggests, hey, this is supposed to be negative. So I also am aware of some use cases for bigger bodies of text where, because transformers are also this thing that BERT has in its internals at some point as well. So for subtlety, I've also gotten the impression that they tend to work much better than the pure language, like word embeddings.
All right, cool. That makes a lot of sense. Anybody else on YouTube has a question?
So I think Lean has one that might be nice to end with. So
yes.
So she says, you showed the pizza flow, but I'm interested in learning what are the most common applications of these conversational agents. So I think like we have different clients and they all have different needs. I do know that most digital assistants that that clients end up with have at least something of frequently asked questions in them, and maybe some chit chat. But then typically you can also imagine, hey, I want to order something. Like that's also something quite typical that you would have. And the way that RASA works is an action can also just be a Python function. So you can communicate with a database. It can also just be an action. It's just like an action as a trigger, so to say. So anything that you can do with a form, you can also do with a conversational agent. It's just that we have some NLP around it to sort of cover more ground, such that you don't have to follow a straight form to get information to a database. And then a final question from Lena is: have you found areas in which they perform significantly worse? I should mention I've only started working at RASA for like 3 months ago, so it's not like I'm the walking encyclopedia of natural language processing. But I will say, at least for stuff I've benchmarked myself, it's like if you super hyper tune the LSTMs and stuff, then you're gonna get maybe close. But transformers just seem to work rather well without having to tune a whole bunch. Like that's the main thing that I find interesting about it. It's like a convolution of sorts, and that, you know, the downside of LSTMs is typically you do end up tuning a whole bunch before it actually fits towards what you're interested in. And to me, that's the most exciting thing about these transformers. But yeah, I think that we have to like move on to the next speaker now in terms of time. Yeah. But yeah, one question actually. So you've been to Switzerland before?
I have, yeah.
Do you know what the main benefit of Switzerland is?
They have good food. I don't know.
Yeah, maybe. Like I've heard their flag is also.
Are you sure you've been to Switzerland then?
Sorry, Vincent. What did you say about their flag?
Oh, it's a big plus. I wish you all a very good evening.
Thank you, Vincent. That was an amazing entrance and exit. Thank you very much.
I will now mute myself.
Right. Amine, with that bar being set that high, I now give the floor to
very
you.
hard. Yeah.
Thanks again.
I'm really nervous following Vincent's presentation and awesome jokes. So let me first share my screen. Okay, again, a bit of inception.
Yeah,
I imagine everybody can see my screen. Okay, so let me start. Hello, everybody. I hope everybody's having a good day and a wonderful week. So my name is Amine. I work at Criteo. I'm going to present, obviously, what Criteo does, just to put everything into context. And I'm going to talk about, again, like Chris said, it's a multiple large-scale representation learning retrieval for online advertising. So I'm going to talk a little bit about each part. So I'm going to cover a lot of things, but maybe quickly. So what are we going to talk about? So like I said, I'm going to present one of the recommender systems that are used at Criteo. It's going to be more of a blueprint in the sense I'm going to present the general parts of the system and how they fit together and the general pattern they fit in. And this system is used at Criteo to serve billions of requests per day, and each request in a few milliseconds. So the focus of the talk is going to be mostly scale, even though there are obviously a lot of other problems that are involved when designing a system like this. So like I said, I'm going to cover a lot of things quickly, but I'm going to try to give you the gist of each thing. So who is Criteo? What does Criteo do? So Criteo does advertising on the open internet. So basically banners with recommended products for users on publisher websites. What is the business model and why is recommendation important to us? Because we buy ad space and we sell clicks. So we buy the ad space and we sell to clients only. We bill clients only when the user actually clicks. And obviously we want clicks that convert. This is a constraint from the client side. We need to generate sales, to generate traffic. So we need the interests are aligned in the sense that we need to show users products that are interesting for them so they can click and convert afterwards. So just to give you an idea of the scale, again, because it's going to motivate a lot of what we're going to talk about. So we do approximately a few billion personalized banners per day. The active catalog size, which is the number of products shared among all our clients, is a few billion. We have like 100 milliseconds to assemble the banner, which counts obviously a recommendation and also creative optimization. And we have a few thousand heterogeneous clients around the world. So the Criteo recommendation engine mostly follows like a two-step architecture that is right now a bit common in industrial recommender systems. So when a user comes and we need to recommend some products to him, so there are two steps. The first one is candidate generation. We pull products from his historical interaction, from his historical interactions. We can get maybe some top sold, top bought products, and we have some personalized recommendations that are generated. So we have a bunch of different candidates we need to choose from. And there is a second step, which is we just re-rank these candidates, we combine them, and we re-rank them in coherence with the client business model. Does the client want more sales? Does he want a better expected sales amount? Does he want, I don't know, a subscription to some newsletter? So there can be different objectives. And we generated the final winner list to generate the banners. So I'm going to mostly be talking about the candidate generation part, one of the algorithms of the candidate generation part. And I'm going to just define a bit the system constraints that we have. So like I said, we need to be able to scale in catalog size. So we need to process hundreds of millions of products. If we have some offline jobs, they need to take a few hours, basically less than a day or less than half a day. We need to be actually robust to offline job failures. So if there are some problems, we need the system to degrade gracefully. We need to adapt to changes in the user behavior quickly. So if the user just saw some product, we need to be able to recommend, to react quickly to that new interaction. Like I said, we need millisecond latency inference or retrieval, depending on what we're going to use. Obviously, it needs also to work better and generate more value for our clients and for us. So these are a bit the system constraints. Like I said, I'm going to be talking about a lot of things. So I'm going to be using this GIF whenever I'm doing some hand-wavy explanation of something. So yeah, please bear with me. Okay. First thing I'm going to just start talking about, which probably most of you know, the matrix factorization framework. So it's the most commonly used collaborative filtering algorithm in the recommendation space. Most of the time, in the literature, they factorize the user item matrix. So where each coefficient is some interaction between, some score of interaction between the user and item, or maybe some rating that the user gave to the item. This matrix is factorized, and we have some user representations and item representations. In our case, we're going to be working with an item-item matrix that we're going to explain, and not the user item matrix. So first thing, why are we working with an item-item matrix and not a user item matrix? In our particular case, items are a much more stable entity. Basically, two users, if they share some tastes in the past, there's no guarantee that they will continue doing so in the future, right? Whereas if two sneakers are similar, they're probably going to be they're going to stay similar for a while. So that's why we have this first focus on the item. Users also enter and leave the system at a much higher frequency. If some new user appears, we don't want to redo some computation or something like that. We want to just be able to generate some recommendations to him, again, in the spirit of reactivity, to generate some recommendations for him. And also because users can have multiple tastes and multiple embeddings, potentially. So that's why we use the item-item matrix. But which item-item matrix are we going to be using? So just to remind everyone of the pointwise mutual information. So if the pointwise mutual information between two pair of outcomes, x and y, that are realizations of two discrete random variables, x and y, the PMI between these two outcomes is just the log of the ratio between their joint probability and the product of the probability of each of them. What does that mean roughly is that if these two items are much more likely to be seen together because they have there is some information in their co-occurrence, this PMI is going to be positive. If these two items are completely independent, basically they're just seen together due to chance is going to be 0, and negative, it means they actually co-occur less often than by chance. What does it mean for the case of products? Well, we just replace the probabilities by empirical estimates from our given data set. So we count the number of times some product X appears, some product Y appear together in the same user history, and we compute the PMI between these two products. So this is just the rudimentary formula. There's a lot of tweaks that can be done, but this is the gist of it. So, okay, let's call this resulting PMI matrix, let's call it A. So we have this item matrix, and we need to factorize it to build some product embeddings. How do we factorize it? Something, again, that I think most of you know is singular value decomposition of some matrix A. We decompose the matrix into a triplet of left and right singular vectors and a diagonal matrix of singular values. And in our case, because we're looking for dense representations, for dense low-dimensional representations, we're going to use a truncated SVD. We're going to make a low-rank hypothesis on A. We're going to say that each product, for instance, needs to be represented by a k-dimensional vectors, and U, it's going to be it's basically U will be will represent our item vectors. So SVD is cool, so we can factorize this matrix, but the problem is that SVD is super expensive, especially for large matrices, both in memory and time-wise. So growing area of research is randomized numerical linear algebra, where the goal is to use randomness to create efficient and unbiased approximations of non-random operations, for instance, the SVD. So we can have actually a randomized version of SVD that works much, much, much faster. And I'm gonna attempt to explain a randomized SVD very quickly. So I put a link here. I don't know if the slides are going to be shared afterwards. I hope so. So I put a link here to the original paper. So again, we're going to put ourselves in a generic randomized matrix decomposition setting. Like I said, we're going to make a low rank hypothesis on A, and we want to decompose it into two matrices B and C, so that the products of these two matrices approximate our original matrix A. So Halko et al. They propose a two-stage pattern. So the first stage is, okay, instead of working with A, can we actually build a Q, like a matrix Q with L orthonormal columns that actually captures the action of A? What does that mean? It means that if I compress the range of A with Q star and decompress it with Q, I get back my original matrix A. This is what this represents. So if I multiply A by Q star and then by Q again, I get back approximately A. And if I have this matrix Q, I can actually use it. This matrix is much, much smaller than A because it has only L columns instead of the original N. I'm going to use it to complete the desired matrix factorization. So in the case of SVD, imagine we had access to Q. All I need to do is, instead of doing an SVD of A, I can just multiply A by Q star to have a matrix B that is much smaller, do the SVD of B, and then just multiply by Q again the left singular vectors to get an SVD of A. So the gist of it is, instead of doing an SVD of A, let's do an SVD of a smaller matrix B. So the algorithmic challenge is just to efficiently compute this matrix Q, because once we have it, we can use it and we'll get something fast. So how do we actually get matrix Q? Again, it's going to be almost the same idea as before. So technically, a very good matrix Q would be the Q and the QR decomposition of A. Because we said we need a matrix that approximates the range of A. So their columns is going to be an approximate basis of A. A good basis is the orthonormal basis of the range of A, which can be obtained by QR decomposition, but it's very expensive. How can we avoid doing QR decomposition of A? By actually doing a QR decomposition of a surrogate matrix that is smaller than A, that we're going to obtain by multiplying matrix A by a random matrix omega. So I'm gonna, because in the interest of time, I'm gonna just skip this part. So what do I need to remember if you forget everything I said? To do a randomized SVD on A, the gist of it is don't decompose A, it's too big. Decompose a smaller approximate version of A. And we actually wrote a library for that. At Criteo, this is what we use in production. It scales, it's pretty cool. So good, now we have our product representations. How can we, so we have only one part of the equation. We factorize this matrix, we have some product embeddings. How can I use them to build now user embeddings in the same space? How do I go from a user interaction history to a user embedding that I can use to generate recommendations? There are multiple ways. I'm going to describe something that might seem very, very simplistic, but it's actually not that bad, at least in the first version that we used a while ago. Why don't we just average the product embeddings of the user timeline? Just a plain average, or maybe weighted average or something like that, but just let's average them. This is what we put in production for the first version because we needed the baseline and it worked quite well. But why does that even work? Like we're doing some averages of some unrelated products, maybe we'll get some weird user embedding. So I'm going to try to explain at least my intuition why it's maybe not that bad. So imagine the user embedding is a sum of like some sneakers and a mug, for instance. And imagine I want to recommend some sneakers. We're going to use as a similarity the dot product between the two vectors, between the user embedding and the product embedding. So again, because I have just the sum, so it's just the sum of the dot products between the two sneakers and the mug and the sneakers. So technically, if our embeddings are good, the similarity or the dot product between the sneakers and the mug is going to be 0. I put a very strong hypothesis here that the topics, quote unquote, are orthogonal. Shoes in general are orthogonal to mugs, which may not be the case, but this is just some intuition. So basically, the components corresponding to the mug will just disappear, and we'll only be left with the similarity between the two sneakers. So even though I did an average, when we did the dot product, we only retrieved the correct components of the user representation. So what do you need to remember in this part if you forget everything? Actually, a simple combination of past user interactions works well in practice. Again, we're trying to go for scale now, so we're trying things that are very simple, at least in the first versions. Okay, good. So I have user embeddings now. I have product embeddings. I just need to get the best product by taking the best, the most similar products to a user, right? So at each request we receive, we just need to compute the user embedding. Easy. We just use some very simple function and generate the candidate recommendation by just issuing a maximum inner product search in the product space, right? Obviously, we don't want to compute the user embeddings similarity with each one of the products by brute force. That's where approximate nearest neighbor search comes. So there are a lot of approaches to approximate nearest neighbor search. The one where there is most research, at least right now, is graph-based nearest neighbor search methods. There are multiple ways to do that, but all of them share at least some similarities. So imagine I have some data points, some vectors. The first thing that is done by these algorithms is to build an appropriate graph of the data. This is where the magic happens, basically, building this graph. When searching for a given query, all we need to do is we start from some entry point that can be random, for instance, and we navigate the graph in this manner. We start by an entry point and we say, okay, amongst the neighbors of the entry point, is there some point, some vertex that is closer to the query than the current point? If it's the case, I navigate to that. And basically, by doing just navigating from neighbor to neighbor, we get closer and closer to the query until we can't. And then we do a brute force search in that neighborhood. This is mostly how most graph-based nearest neighbor methods used. So the ones we used are called hierarchical navigable small world graphs. So again, if you need to remember one thing, is approximate nearest neighbor search or maximum inner product search has come really a long way. So it works very, very well. There are libraries that are ready to use, just use them and abuse them. They work very, very well. So the one we use in production is, like I said, HNSW-lib. We wrote some bindings, we changed some things in it to use it, but there is a very good library by Facebook AI Research called FACE. Just use it, it works magnificently. You can do queries up to like billions of points. It works very well. So how fast is all of this? So let's say this is our system. So we have the user embedding computation and the recommendation retrieval is run as a separate service. Like I said, it's only one of our candidate generation algorithm. Just to give you an idea, each instance of this service has 4 CPUs and 30 gigabytes of RAM. So it's a fairly small machine, not that big. So each one of these instances can handle a load of 4,000 queries per second, which is pretty huge. With actually a few millisecond latency, like the 99th percentile, just 4 milliseconds. So it's very, very fast. So obviously, because operations we did are simple, the nearest neighbor search is non-trivial, but that goes to show you that these libraries actually work very, very well. So the system I showed you is just an instantiation of a general pattern that we use. This is not the system we have right now in production. It was the first version. What is this general pattern? Let's denote P, the product vectors used by RSVD. The first thing we do most of the time when we have a new system to build is to have an adaptation layer that instead of using the raw vectors, we have this layer G that adapts these vectors to the given task. When I say task, it's maybe click prediction, sales prediction, something like that. And the user embedding is just a function, F, of the products he interacted with in the past and the context. In our previous case, F was just the average of these embeddings, G were just the identity, and the context were just unused. But basically, whenever we have all our newest recommender systems, they follow this pattern. We have some F and G that are actually optimized and end-to-end to solve a given task. But to make sure this system is actually deployable in production, we just need to make sure that the score of a product is an increasing function of the dot product between the user and the product to actually continue doing maximum inner product search. So, so this is the general pattern that we use. I'm almost out of time. Well, I am out of time. There's a lot of things that I did not cover. How do you measure this? Offline metrics. So it's a hard topic. The TLDR is that we use a mix of classical metrics, recommender metrics, and we use quite a lot counterfactual metrics. So I put there a link to an interesting paper there. To do online evaluation, how do we evaluate? Obviously, we A/B test all the changes in the system every 2 weeks, and we had several successful rollouts, basically modifying F, modifying G, and this is basically what guides our experimentation. What if we have too large embeddings, they don't fit in RAM? Quantization is a very interesting topic. I put some link there for the people interested. How do you do fast inference if you don't want to have an average, you want some fancy model? We use right now XLA, which is basically a graph compiler for TensorFlow, a graph compiler and a graph optimizer for TensorFlow. But again, if you had to remember 3 things, you probably know these already, and because I also needed to put some conclusion and not stop there. So Large-scale machine learning, at least in our case, is really constraint-driven development. So we have an idea, and there is a constraint that hits you in the face, and you need basically to navigate the solution space guided by your constraints. Basically, it's in engineering, like any engineering discipline. Randomization, approximation, make everything faster. If you can afford some mistakes, do them. It's gonna make everything faster. And baselines, just start with something simple, especially if you're working in production. You might be surprised by its performance. Don't dismiss simple baselines just because they look simple. Most of the time they work very, very well. And with that, I conclude. Thank you very much for your attention. And are there any questions?
Cool. Thank you very much, Amine, for your presentation. Let's wait for some questions popping up from the chat in YouTube. So in the audience, if anybody has a question for Amine, Vincent has a question. Go ahead,
Yes.
Vincent.
No, because like I seriously thought that like the trick to sort of just take the average of all the item embeddings, I'm actually quite charmed by that. That feels like a valid sort of place to start. One thing I'm kind of, yeah. Okay, well, I thought you said it wasn't, but
No.
like as a place to start, it feels very valid. One thing I wondered, do you also, would it make sense to keep the order in which the items were purchased in mind as well? Because I can imagine if this is an online shop, what I bought a month ago is going to be less relevant than what I'm looking at in this session, I can imagine.
That's actually a very, very good question. So this is the, so I would say this is the main drawback of using this simple combination, is that if the user bought item A and item B, or item B then item A, you would treat these in the same manner. So what we're testing right now is actually not trying to go beyond that, but staying simple. And the way we do that is actually almost the same trick that is used in attention models, which is just encode either the time position or the position of the product, encode it with an embedding and add it. So you can keep this average simple thing, but having either a trainable positional or time encoding.
Right. But you don't reweigh the embedding, like you don't reweigh the embeddings themselves. So you could say, oh, this happened more recently, that gets more weight. That's what you're not doing.
This is the first. So no, actually, this is the first version we did. This was actually what's put in production, like some with a half-life decrease in weight over time. But you would be surprised. It's not obvious. It's not obvious because sometimes it works. Sometimes it works, but for some items you want to keep actually a longer memory. Maybe some item, even though it was purchased a month ago, maybe there's still some relevant information.
Yeah, with fashion, that can definitely. With fashion items, I can definitely imagine that being the case. But with a light bulb, it would. For
sure. So that's why this time component is mostly trainable on our system. To keep that in mind, that the temporal interactions can be quite different between item types.
Cool. Thanks.
All right. There's a question from Lynn. She says, thank you, Amine. Really interesting. I love how you pointed out that simple baselines work, because that's also my experience. Any other surprisingly simple solutions that work really well that you can share?
Okay, maybe something that is not. So something that actually works in general, I would say for any recommender system practitioner, and I think every recommender system practitioner works very well, is comparing to just top sold products, or any modification of top sold products actually works very well. Example, if you take the latest categories that the user saw and just take the top products used in the latest category that the user saw, this is actually a hard baseline to beat. So starting from a general baseline and trying to personalize, having some personalized best ofs kind of approach actually works very well in practice, and will give you a challenge, at least in an industrial setting. It does give you a challenge. What else? There are quite a few. That I would think it's the best thing. Like, we always compare ourselves to these personalized best ofs, because these are basically our top challenger.
All right, cool, thanks. I have one more question myself, not about the algorithm, but you did mention a few times that you work with quite a lot of data, you have a lot of users. And also speed is important for you. You measure like your 99 percentile was in 4.5 milliseconds or something. Can you share a bit about what kind of hardware and infrastructure are you running on? Is this all on-premise? Do you run in the cloud? If so, which cloud? Which technologies do you use? High level.
Of course, this is a good question. So the high level thing is that we operate everything on-premise. So we don't use cloud providers for several reasons. Maybe it's not true anymore, but at least a while ago, it was hard for cloud providers to give guarantees on latency. Because obviously the machines are shared between several applications, and you can get some dedicated machines, but it just will cost so much that you better get your own. So we operate on premise. For cluster managers in general, so most of these machines are managed like in an Apache Mesos cluster. So Mesos works very good. Basically, the way, at least right now, we interact with these machines, it's like we have our own internal cloud provider, right? So you can also reserve machines. You can deploy applications in machines. You can scale up, scale down by using a combination of Mesos and Marathon. So yeah, that's it for the offline part in the computation. So there is Yarn. So it's a Hadoop cluster with Yarn, so you can run Spark jobs and stuff like that. So we work a lot with open source, basically software, but using our own in-premise data centers.
Cool. There's two other questions that popped up. I'll quickly go through them, although we're a bit over time, but I think they're both interesting questions. So one is from Bart Goethals. He asks, how do you optimize a model like this for conversion?
Yes, this is a good question. So can I reshare my screen?
Yeah, go for it. I'll broadcast it again.
Yes. So let me come back into the general pattern. If you can see my screen. So there is, like I said, there is an adaptation layer that adapts these product embeddings that are built using this organic data. So this is our first function G. And there is also something that combines these products, some function F and the context to get some user embedding. This can be trained, F and G can be trained to solve the task. So if your task is knowing the user history, tell me which product he's gonna buy in the future, you can actually just optimize for that. So get a data set with user histories and some products bought in the future, and optimize for that. For instance, by having some pairwise ranking loss, at least this is what we use, some pairwise ranking loss, where we sample some products that the user saw but didn't buy, or some products that the user never saw, the product that the user bought, and trying to make the user representation closer to what he bought than what he didn't buy. This is at least how we do it in general. I don't know if it answers your question, Bart.
Yeah, let's see what he says. In the meantime, I'll go to the question of Frederik quickly.
Of course.
So Frederik says, how stable are the product representations across time? And to what extent can the system explain why a certain recommendation was made?
Yes, so this is a good question. So how stable are the product representations across time? They're actually pretty stable. Like, again, it depends on so the time period we use for building these embeddings is a few months. So basically having one day, and actually even though we don't need to, we do rebuild them every day. So day after day, it's a slow drift. But if we wait maybe for a month, the drift is a bit bigger. But in general, they're stable. The second question is, to what extent can the system explain why a certain recommendation was made? So something that we can use, and what we do is, in the case of the simple average model, you can actually get the dot product between your recommendation, or the similarity between your recommendation and each one of the products of the user history. And it will give you, in some sense, how much this product contributed to the overall dot product, right? It's like what I said before. So a product that was completely dissimilar with your recommendation and the dot product was 0, it's like he wasn't even there, basically. So it didn't contribute at all to the recommendation. So this is also an advantage of using something simple like this. Yeah, I hope it answers your questions.
Cool. Yeah, I think it does. I mean, thank you very much for the presentation. We have to go to the final presentation of today, but it was really interesting.
Very much.
Thank you very much for joining the meetup. All right. Well, and then the final speaker of today is a Belgian person, so not from Paris, not from Berlin, not from Amsterdam, but from Brussels. Hi, Sam. Welcome. Welcome to the Data Science Leuven meetup.
Hello, Chris.
Hey, and you'll be talking about robotic process automation and compliance, right?
Exactly.
All right, go for it.
I would have loved to see you all at the Naamse tonight, but unfortunately, I will also try not to mention the C word tonight. I want to talk to you about the future. I want to talk to you tonight about data and compliance and robots. I want to talk about a future that uses RPA, and even broader, a future where businesses are doing business with robots. Let me just share my screen. Entire screen.
Yeah,
Yes.
it's coming. There it is.
Yes. Can you see it?
Yes, we can.
Good. So I have Vincent talked about Transformers tonight. I saw Amine talking about The Matrix tonight, and I want to talk to you about a movie tonight as well, being this one, Terminator. He was born in the year 1984, the year in which James Cameron released The Terminator. And I think it's a very good movie. And why is that? Is it because of Arnold Schwarzenegger? No. It's a movie that gets under your skin. It's a scary movie. And why is that? Because it's a horror movie. And not like nowadays horror movies with blood and stuff and so, but horror in the essence of the genre, an existential fear. Back in 1984, the people believed that robots, they feared robots because they couldn't imagine robots in everyday life. If people were thinking about robots back then, they would imagine either a Terminator or either something, completely insane, like a microwave suddenly standing in your kitchen with a knife. Luckily, the future turned out not to be so hostile. Now, before we start, maybe a little bit more on myself. I'm 35 years old. I live in Brussels. I studied at the KU Leuven. I started working in business development. I moved abroad to the Far East and the Middle East. Afterwards, I came back. I started working for 3D printing leader Materialize. I worked in e-commerce for Worldline, and currently I'm business development director for Altara's Dun & Bradstreet, which is a global leader in data. I work from their Brussels office. And when I talk data, I'm talking financial data, compliance data, supply chain data, and sales and marketing data. Now, back on robots and data and compliance. Who has a robot at home? This is Sophia. This is a robot built by Hanson Robotic in Hong Kong. You should look her up on YouTube. You will be amazed at what she, or better, it can do. Everything is already possible. Robots are omnipresent. Who owns a vacuum cleaning robot? And who's got an Alexa at home? Who uses Siri? In fact, it's strange how quickly robots became part of our everyday lives. One of the books I found very inspiring is The Third Wave by Alvin Toffler. It's an old book back from the 80s, but in fact, it describes an evolution, a first wave of agricultural developments back in the Neolithicum, a second wave linked to the industrial age, mass production, mass consumption, mass media, and then a third wave, the post-industrial society. This third wave is also called the information age. And one of the key takeaways of the third wave is the fact that robots will be instructing us. And this is currently something you already see happening when you get reminders from your Outlook calendar, when your iPhone tells you how quickly and via which route to go home. Robots are omnipresent. They in fact built self-driving cars. So robots building robots. E-commerce. Nowadays, 95% of some fulfillment centers in e-commerce use robots to replace manual labor. And this already happens. Robots doing business with robots also already happens. A good example here would be the refrigerator from Samsung. And I'm not paid for this. This is not sponsored content. But the fridge can automatically place an order without manual intervention. So this is the fridge. If your fridge is empty, if it's out of milk, it can automatically order new milk. This, in fact, is an automated ordering process. It's a simple relation. Money is taken from your credit card in return of delivery of the product. And they also have same-day delivery. If my fridge is empty, it can be delivered the same day already. And it's good and important to understand that customer experience is a key driver here. Nowadays, you want to be helped very quickly as a customer. And look at yourself. If you're shopping online, bol.com, Amazon, Coolblue, if you can have the object the same day, that's quite appealing. And so it's very important to understand that customer experience is our judge. I mainly talked about applications about robotization in the consumer market, but as a geek, my heart is beating a lot faster from these data applications. Certainly when it concerns international business, mainly the business-to-business applications grab my attention. What we see there is, in fact, we all know that computers, because robots, in fact, are ones and zeros, they are more efficient than humans, more objective, more accurate than humans. And as we head towards singularity in the age of quantum computing, robots will become smarter than us. So you will get a complete different set of debates and topics such as moral autonomy, moral decisions. Should robots eventually have their own identity? And what if robots really have some kind of consciousness in the future? I think these are real interesting issues we as a society should address. Then back to the business world. The Friedrich Alexander Universiteit in Nuremberg recently conducted an experiment, in fact, a simulation of the stock exchange trading behavior between 1992 and 2015. And they used deep learning techniques to answer the question whether a computer could make profit by buying and selling smart from the stock exchange. And the computer, in fact, managed to make a 30% profit per year. The researchers got the system to make predictions about each trading day for the 500 largest US companies. And the great thing is that during the crises, the computer made the biggest gains by far, especially when compared to people who were in the trading room themselves. And why is that? Because people are making their choice based upon emotions. And a robot, of course, doesn't do that. Now, let's imagine a world where the whole economy becomes automated on a global scale. And this is something we are heading towards. Where can I buy the best raw materials? How can these raw materials then be shipped the fastest? Which carriers to take for this? Which channel is the cheapest? Where to stock my items? And what's the optimal period? Basically, it's no longer is a simple relationship, a simple transaction between my fridge and my supermarket, but it becomes part of a larger economy, an interdependent economy with suppliers, buyers, carriers, customs, and so on. Marketplaces will arrive much more than today, and a lot of transactions in the future will be fully automated. Because of this, it will be crucial to have your data managed correctly. Master data management is key. This is something we can predict for sure. And again, customer experience is the key driver in a globalized economy. Just as we want our package from bol.com to arrive the same day, it's faster, more accurate, cheaper, more reliable. We will see this in the global economy as well. And this meetup is full of data professionals, data science professionals, and I know a few of them myself, and they're a bit suspicious by nature. Who is going to monitor these lightning fast transactions? What if transactions disappear from view? You should think about the cryptocurrencies where the central banks have a lot of troubles with. How do we combat money laundering in an era where artificial intelligence is no longer only reserved for technology companies, but might also be available for criminals, for example? Who is the ultimate responsible for robots doing business with a robot? These are legitimate questions, and I think the answer is not that hard to find. The Rathenau Institute told us that about human rights in the age of the robots. And we have the right not to be measured, not to be analyzed or influenced, and we have the right on human contact above robot contact. We have the Microsoft CEO and Stephen Hawking. They have insisted on regulation in regard to algorithms to steer AI. And the same principles about robots are valid for RPA. When there are fixed rules and routine checks, smart software can help to streamline business processes. So who is the final responsible? It's the human, of course. And when we return to my fridge, who is the ultimate responsible? It's me. On the supermarket side, it's a little bit more difficult. If robots are doing business with each other, we can conclude final responsibles are natural persons instructing these systems, managing their policy. And if you see this picture, I'm not sure anyone has ever seen this. This is a picture of a test of self-driving cars on public roads in California. And the car manufacturer wanted to measure the impact on pedestrian behavior, not seeing a driver when crossing the road. But of course, research institutes back then, and now of course as well, according to local legislation, they're not allowed to do testing of cars driving around without driver. So they made the drivers disappear, not to have biased results. Here you see the concept as well. It looks a bit funny, but this is actually happening. And you can see here as well that the natural person is the ultimate responsible. And what happens if my fridge orders 3 pallets of milk? What happens if a Tesla gets me into an accident? What we basically see is that when we're looking for a better customer experience, it will lead to more innovation, more automation, faster delivery, better processes. And on the other hand, we see compliance, we see legislation, we see regulations, less innovation, more security, more safety. And this balance is very important. So we're talking about customer experience and innovation versus regulation and compliance on the other hand. And the correct judgment to do this, what is the balance? How can we assess this in a good way? Here, data is key and data will help. And in order to make the right decisions, organizations will need to become more data-driven. And at Dun & Bradstreet, that's our core business. That's something we have done since we were founded in 1841. And back then, everyone knew the business partner he or she was doing business with. That, of course, changed when the US economy expanded to the West with the railroads. And people were doing business with people they didn't know. And the problems back then are maybe even the problems today. Who am I doing business with? Is this actor trustworthy? And if a business actor back then was not trustworthy, a bounty was put on their head. And Dun & Bradstreet set up a system with correspondents throughout the whole country, verify stuff, validate businesses. And they would go and ask in the local community, do you know this company? They went to the saloon to check, they went to check the address. And these former US presidents have all worked as a correspondent for Dun & Bradstreet. And a very concrete case, imagine this is the company of Mr. Pitt, the ultimate beneficial owner, and that's a quite important concept in compliance. Ultimate beneficial owner, the UBO, here is quite clear. This company has 100% ownership by Mr. Pitt. Even if there was a company, because back then the rules about companies and private possessions were not that, the difference was not that strict. It's not as important as today. Nowadays, what we see is these kind of structures in a globalized economy. People and organizations with bad intentions, they have a lot of possibilities to set up covers and to hide away money. And what Dun & Bradstreet does, in fact, is to collect and connect data from over 350 million of organizations. And we do this by collecting data from tens of thousands of sources on a daily basis. We have a lot of information about financial numbers. We have a lot of compliance information. And in fact, it's the largest database in its kind globally. So if you have external data needs, data scientists, you're working on interesting cases, please come and find me. I'm sure we can help you with AI projects. What I wanted to conclude with, that we have compliance legislation and regulation. We have innovation and more safety and security, and the balance is important. What we believe is that data is the solution, also for the challenges of today. So my final wrap up is ownership. You are responsible for the processes, for the decision and the outcomes of the robot. Data management is key. If automation increases, garbage in, garbage out as well increases. So robust data management is key. Not to have 3 pallets of milk through a wrong functioning API or address. The third thing, the customer is to be put central. Keep an eye out for competition that quickly onboards, and do use the right data and the right technology. And the fourth takeaway, I would say, is go beyond compliance. Make an analysis. How do you make your decisions today? How will you make them in the future? And is your decision model, your risk model, are they future-proof? So make sure to keep these things in mind. Voila, that's it for my part today. Are there questions?
Cool. Thank you very much, Sam, for your presentation. So while we're waiting for questions on YouTube, maybe let me start with one question. On your last slide, you showed. Can you share your last slide again?
Yeah.
Oh, it's coming. It's always a few button clicks. Yeah. Here it is. Yeah. So you say robust data management is key. Can you maybe, from the field or from your experience in real life, can you share a bit like the lessons learned there? Like, what do you see going wrong in data management, and what do you do then to fix it? Can you give a few examples of your lessons learned there?
Yeah, what I think is very important is that your master data management is set up in the right way, that you have a process for this and you have good tools for this, because garbage in is garbage out. And what we often see, for instance, that if you have a CRM or an ERP system, and you are a multinational organization acting on a global scale, shipping items all across the world, you have a lot of branch offices and subsidiaries on different continents, and they all have their siloed information. They all have data silos. And what is key there is a good functioning central data strategy, where you have master data managed by a single actor or a single system, and you spread it from there through the rest of the organization. But you have one golden record, you have one driver, and I believe that is very important, because if we open some of the CRMs of our clients or ERPs, we see suppliers, the same supplier we see with 25 different names in the CRM. So we see abbreviations, we see legal entities, we see commercial names, we see old invalid legal entity names, and so on. So you see there is a lot of pollution in a data set. Yeah.
Have you maybe a cheeky follow-up question, but have you ever seen the opposite? Because what you described, that's like the only CRM system I know. Yeah. It's like always, we have 5 different CRM systems because as a result of a merger, and they had another CRM system. Oh yes, and we have like 6 different entries for this client and this CRM because blah 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 blah. So to me, but I might be turning into some kind of cynic, but I've long accepted the situation when we have to integrate with a CRM system or even ERP system. We know that there's going to be a lot of garbage, and we'll have to.
Of course. Of course, you have your legacy data, and then you have the fact that your current data gets polluted. Every year you have 1 or 2% of outdated data. So companies stop existing, they go bankrupt, into failure, liquidation, but the data stays in the database. So what we have, in fact, is one global unique ID. It's a DUNS number. It's a global unique identifier, and using this DUNS number, you can set up a CRM or ERP in a very structured way, because you have one global identifier for these 350 million companies worldwide. And if you say, we are talking to this company in Indonesia, this is our supplier, even the branch in Mexico can, via the DUNS number, and that's the only global unique reference for businesses, in fact, you can then, with this number, the unique DUNS number, you can bring order to your CRM and ERP environments. So it can be set up in a good way if you have the right tools and a strategy for it. Yeah.
All right, cool. Well, I see a follow-up question from Istvan, which kind of connects to this topic. He asked, like, how is your approach technically different from what the competition does?
Well, I'm of course not here to answer on what the competition does, and certainly not from a technical point of view. But what of course is the major difference is the scope, because Dun & Bradstreet, we have data about 350 million companies worldwide. So if you want to do a transaction, no matter where in the world or via which channel, up to crypto transactions, you can always, via the unique DUNS number, you can identify the legal entity. And this is a unique characteristic that the competition doesn't have on a global scale. So 90% of the Fortune 500 companies uses Dun & Bradstreet data because, in fact, it's the only global covering system for business information. Yeah, and that I would say that the width and the depth of the data, the quality, is the broadest, and therefore we are doing what we're doing very good. Yeah.
All right, cool. Then Bart Goethals asks, can you give an example of a concrete project you have worked on in this regard?
Yes. So a very concrete example is there is a supranational investment fund managed by a supranational authority, which I cannot disclose, but they're funding a lot of projects, and these local governments, they need to do risk assessment where the money will be put into. And this is a very good example of a project where you have an API connection on a central database where the supranational government for approximately 2 million projects can make a risk assessment. So it combines master data, it combines risk data, financial risk, but also compliance. So compliance data, who is the shareholder asking for investments from our fund? Is this a trustworthy actor? Have they been convicted for fraud in the past? Quit anti-money laundering? So these are all questions from a specific project, a specific use case we have worked on and brought data via an API to the supranational government. Yeah.
All right, cool. And with that, we're right on time. It's 9 o'clock. So, Sam, thank you very much for your explanation on RPA and compliance. And everybody on YouTube, thanks for listening. Vincent and Amine as well, thank you also for your presentations. I hope you guys enjoyed the night as well.
Yes.
And hopefully I can get to invite all of you physically in Leuven one day, and we can do this again, but then meet face to face and share it together.
Yeah, I hear the bar is amazing. Some guy told me there's an auditorium in a bar, and it's supposed to be amazing.
It is really good. It is really good. So it would be great if you ever get here. Yeah.
For sure. We need to grab it. Thank you very much.
Thanks, guys.
Thank you all. Take care, guys. Bye.
Have a good one. Ciao, ciao.
Bye.